All right. Good morning, everyone. How are you finding CSS?
It's a language.
Oh, wow, that's a much more positive view than most people have at this point. But that's great, actually, because I usually like it. I like the designy part. I like the process of kind of tweaking rules until the page looks like it should. I don't particularly like turning comps into pages because it just feels a little bit constraining. But I do like designing through CSS. I think it's not something many people do because usually the roles are separated into like the designer over here who produces a design that then like the developer codes. But producing a design in like Photoshop or whatever is not necessarily easier than producing it with code if you have a certain alacrity with code. So I enjoy the workflow of just like iterating on something until you make it look how you want. And one of the things that makes things look delightful on the web today is animations. So today we're going to be taking the page that you made yesterday, although there's a starting point that is like already done, and adding some nifty animations to it. So let's talk about how we can do animations in CSS. There's two types of animations you'll see on web pages today. There's CSS animations and JS animations. And for the most part, we prefer to do animations in CSS because they will be accelerated by the browser in a way that JavaScript animations cannot be. So if you are in a JavaScript animation, you will be updating some property every frame. You'll like set up a callback, usually with request animation frame, and you'll change some property on the page every frame, and the browser will go and re-render it, and it'll look animated. With the CSS animation, you basically say, like, here's the start point, here's the end point, do it. And the browser internally manages the transition from one property state to another. So let's actually look at that. Let's say I have a box. I'm just going to give this a style. Oh, it's not. I'll give this a class box. Click me. And up in my style sheet, which, why would you do that, Visual Studio Code? What's wrong with you? I'll say that all boxes have width 256 pixels, height 256 pixels. What else can I do? Display, table, background, fuchsia. Great. So if I actually, let's do this on hover. Hover me, and I'll say hover glow. Okay, so let's make this background black. And now if I say, I'm going to add a background to the hover glow class, and I'm going to say that when it's hovered, it'll be fuchsia. So now this should be black at first, and then when I hover it, it's fuchsia. So that's nice, but it's not as nice as it could be because it's kind of a jarring transition. So if we want to make this transition smoother, we can add a transition rule where we say that the background transitions in 113 milliseconds. This is like a very simple rule. It's going to take all of the various background properties and smoothly interpolate them so that the fade is much softer. I'm going to make that longer so we can see. 1,000 milliseconds or 1 second. Oh, that's so nice. So soft. So delightful. You can transition all kinds of things. So if I wanted to, let's make this a little bit smaller to start out with. 28. Actually, no, let's not do that. Let's do it this way. Let's say that it starts off with a transform scale 0.5. So now this box is going to be smaller. And when we hover it, it's going to be twice as big as it was. So now the background is transitioning, but the scale is not. The transform is not. I can change that, of course, by saying this should also transition. And now we have a zooming box. It's maybe a little bit dramatic. Maybe I should make the scale 1. Isn't that nice? It feels like it's just leaping up to touch the cursor. Okay. So properties that you can transform, or properties that you can animate smoothly are, they're not limited to these, but these are the ones that are generally safe. Transform, when you apply a transform to an element, especially if you animate that, it will generally be popped out into its own compositing layer. You can actually go see if that's happening. In the rendering tab, let's see, show layer borders. Yeah, it's there. Can you see that? Wow, that is really not very visible. Show layer borders, olive, orange. Yeah, do you see how like there's a little orange halo around this thing? So it's being popped into its own layer. We can actually fake, or we can force it to be in its own layer forever by saying translate z0. Oh, wait, what? Oh. Let's spell translate correctly. Yeah. Yeah, it's really not very visible, unfortunately, but there is this orange border around it. And notice that now that orange border is like there forever. When I didn't have this rule, the browser was putting it into a layer and then popping it out of the layer. So what is a layer? When this page gets rendered, the browser goes and takes all the elements and creates a scene graph. So it figures out basically if you were to represent this page like it was a Adobe Illustrator document or a PDF or something, what would all the graphical elements on it be and where would they be positioned exactly? So it does the layout thing and it applies all the styles and it comes up with sort of this vector image. And then it needs to figure out, okay, how do I paint that onto the screen? And in some cases, it'll just paint things directly on top of each other in the same buffer so that if one of them changes, it has to repaint all of them. In other cases, it'll create a separate layer, actually a separate part of video memory. And then it can manipulate those layers independent of each other and composite them all together at the end. When you say something, basically when the browser is changing something like the transform of an element, it's going to have popped that out into its own layer, which can be hardware rendered, it can be hardware composited on the GPU very quickly. The GPU being the graphics chip that is like very good at graphics and pretty good at mining Bitcoin and not very good at anything else. Okay, so you saw, so the trick I was using here of doing translate z0, what that is saying is I'm applying a z translation, like a 3D translation to this element. I'm not going to talk too much about 3D effects, but you can set up a perspective box and do 3D stuff in CSS. But by saying translate z0, I'm basically telling the browser this thing should be in its own layer because it is being moved in 3D always. And the reason you'll sometimes see this is because people want this animation to start off without like any delay. That is, without the delay of putting this thing into a layer to begin with. pretty imperceptible in this case because the animation is simple, but there's like a very minute delay where the layer has to get created. The better way of specifying that is to say that transform will change, which I think, yeah. When I do this, I really wish this border was more obvious. Maybe if I just make this white. Oh, there. Hey, sweet. Okay. Okay, so without will change, it's not. It starts off not in a border, not in a layer, and then gets popped into a layer when the animation starts. If I specify will change, it starts off that way. So that's nice for performance. There's also a cost associated with this in that basically layers aren't free, they take memory. And so if you put will change, you could just be like will change, I think all on, oh no, it's not all. I guess maybe all is not an option. But you might think like, oh, okay, on every element on the page, I'm just gonna say that it's, it will change its transform. And that'll just mean that everything's in a layer, and that'll be great, right? Like I can move anything on the page around, and it'll be fast. Except the whole page will actually probably be a lot jankier, because all of these things that aren't being moved around are consuming resources. It's like the browser is sitting there in a high anxiety state, ready for you to animate any of these things. So the general advice that you'll see if you look up information about this rule is apply it for as short a time, apply it before the thing actually changes, but for as short a time as possible. Things that are going to be hovered are a decent example of something that can have will change. Ideally, you would want to apply it only when they are actually in the viewport, which is something this workshop will teach you a wrong way to do that. I mean, wrong because there is now a better way, but like literally there is now, as in like a month ago, a better way came out and started being popularized. The workshop will say you should use get bounding client rect to, here, let's see. So if I call this get, really? Oh, H1. So if I call get bounding client rect on an element, it tells me exactly where it is in the viewport, including if it's not in the viewport, which you can use to figure out like, oh, is it visible on screen? Is it like intersecting the viewport? The problem is doing this requires the browser to relay out the page for reasons I'm not totally clear on, which is very expensive. And so there's sort of a hacky workaround in the workshop for how to improve the performance of fetching the client rectangles. But the actual preferred way to do it now is with an intersection observer, which literally does exactly the thing you want. It provides a way to asynchronously ask when something is entering the viewport. So do what the workshop says, and then maybe look this up as extra credit that's not yet in the workshop to see how you're supposed to do it. And as with many of these new technologies, there is a polyfill available. So there's a library you can throw on your page, which makes this API available even in older browsers by calling get bounding client rect in the background. But then on newer browsers that support it, like this version of Chrome, the performance is much better because it doesn't have to relay out the page. It's just literally watching when something comes into it, when an element comes into it. Okay, questions so far? Okay, that was a brief digression into browser rendering performance. To continue that digression, properties that are pretty likely to be quickly transformable are, actually I'm going to keep will change. Transform, all transforms can be applied, they're all like single matrix multiplies performed on a layer, so they're very fast. Opacity is like the canonical compositing operation that your graphics card does very fast. So it is a fast thing to change. So this should now fade in some cool way. That doesn't look very different. And then transforms cover a lot of things. So I can scale it, I can rotate it. I think I can do here. Okay, look, I'm going to try doing a rotate 3D and see if I get this right. Clockwise rotation by the angle specified in the last parameter about the XYZ direction described by the first 3 parameters. Oh my god. So let's say I want 0, 1. Is it commas? 1, 0, and then 45 degrees. I think this is going to break everything. That totally broke everything because I do need commas. Oh yeah, so that is in fact doing a 3D rotation in addition to the 90-degree rotation. It's hard to see though because we haven't set up a perspective on anything. If we did that, perspective 1 pixel. Oh. Whew. Yeah, I'm really deeply unclear what's going on there. Why? But my suspicion is that it is applying the rotation, and then as it's applying the rotation, it's actually no longer under my cursor. Yeah, that looks like what's happening. So it stops applying the rotation because I'm not hovering on it anymore. So then it like goes back, which then causes it to fall under my cursor, so it starts twisting again. That's cool. I created a resonance effect in CSS. Oh, there, we got it. Yeah, okay, CSS, 3D is a little bit hard to work with. But that's how you do it. You set up perspective on the parent, and you can use 3D transforms, and they'll work how they're described as working, which is not always completely intuitive. Let's go back to 2D. 2D is easy. I can reason about 2D. Okay. So any of the affine transformations, opacity, those are the safest to change. And then, background colors, text colors. Here, let's do color black, color white. Also do 256x, vertical align, middle, font size, 20 pixels. Text align center. Oh, I didn't tell it to animate color, but color is pretty nice to animate too. Okay, so it's nice, right? I would make a whole website made out of just effects like that. What are some other things that you can animate productively? Actually, let's talk about another way that you can animate things. So this is CSS animations with transform or transition. You can also animate with keyframes. Animations with keyframes. And when people say CSS animation, this is kind of more what they mean. These would be CSS transitions, so I should just call it that. Okay, we don't need this perspective parent. That's just going to be confusing. So what do we want to do? Let's make the box like move over and change color. So when I might have a lot of properties that I want to change. I might also have I might want like basically a more complex script than transition gives me. So if I specify transition, I have some control over how these properties change. So for example, I can specify the easing, which I might have to look up how to do this. Like, here, let's actually just say, this is a nice trick. Transition everything, and ease. That might be the default. Let's try like ease in. So it's a little bit hard to see, but can you see how changing this property has, let's make it linear, has a perceptible impact on the animation. So this is linear. It's just like changing everything smoothly. This is ease in, where it sort of accelerates and then slows down. There's ease out, which does the opposite. And there's a few others too. This is what the parametric curves. Ooh. What? Why? Why would you do that? Okay. This is what the parametric curves look like for each of these. So this is like how far along the animation is over time. Linear is just like 1-to-1. Ease is sort of sloping. And the reason you might pick one of these other curves is linear looks sort of the smoothest, but it's not the smoothest in the first derivative. So there's actually a jerk in that the change in the rate of change at the very beginning of the animation is not continuous. Whereas with the easing curves, so they have this, they feel smoother, even though they're like more complex mathematical curves. All right, so you can animate basically any, wait, was that us? Yeah. You can animate basically any property. These are the ones you like probably should animate. But you can go and like, but it still gives you a lot of power, right? You can move stuff around, translate pixels. When you're applying multiple transforms, the order in which you apply them matters. Interestingly. So generally you want, if you want the translation to apply not rotated, you want it to be first. It applies in the order that matrix multiplies would apply, but basically it goes left to right. Well, no, it goes right to left. That's the way of articulating it that makes the most sense. Like if I put translate first, the translate will happen before the scale, which means the translation will not be scaled itself. Okay, so if I want a more complex animation, I can specify it with keyframes. And let's also take this moment to show how we can trigger an animation with JavaScript. So I can put in, man, I really want to be typing JSX right now, but not. Apply animation. I wonder if that works. Let's find out. So I've got an event listener here. Let's actually, here. shouldn't use onClick properties in raw HTML. I'll give this an ID, clickable box, and say get this element, add an event listener to this element so that when it's clicked, what's going to happen, we'll start animation. And the start animation function is going to look at the target, which is the box that this thing happened on, and look at its class list, which is, remember from, I think, Game of Life, it's the way you can quickly add or remove CSS classes. And we'll add, how about rainbow? Okay, so now when I click on this, yeah, that worked. When I click on this, the rainbow class gets added to this box. Right now that does nothing, so let's make it do something. The rainbow class will apply the animation rainbow. And I think I need more than this. I think I need to say here, I can break these out. The animation property is a shorthand property for all of the other animation properties. This animation name, duration, timing function. So let's say name, oh, here we go. Animation, 3 seconds. The timing function, sure, ease in. Delay, I'll do 0, and then the name, I'll call it rainbow. And then I need to specify what this animation does. So I can do that with a keyframes directive. And here I get to specify a timeline of what is going to happen to this element as the animation progresses. So a simple animation looks like from to red, yellow, green, blue, and go violet. Oops. Wait, did I? Oh no, that was correct, I think. Oh. And then notice what's happened. I click this, the animation happens, and then it's done. After the animation is done, by default, the animated properties don't stick around. You can change that by, let's see. I think by saying animation fill mode both. Oh, what are my options? Backwards. So this basically says how should the state of the animation fill after the animation is done. If I say forwards, then the last frame will stick around, so it won't jump back to violet. Oops. No, it's just going to be a rainbow forever. Or it's going to be violet forever. If I wanted to just have it loop, I could say, let's see, delay iteration count. I could just say animation iteration count infinite, and then it'll just go forever. Okay, also, this is not a very useful use of keyframes yet, so let's change that. in addition to saying from to, you can specify percentages. Yeah.
If we have multiple animations, like if we're having one animation, an animation field more forward will keep the last animation.
It'll keep the last frame, basically. When it basically defines the state of the element after the animation is over to be whatever the last state of the animation was. Otherwise, it's whatever the non-animated properties of the thing are. Okay, what is it? Red, orange, yellow, green, blue, indigo, violet. What's 100 divided by 7? 14.2, great. 14%. You know, I think dividing it by 5 will be easier, and then we get the pride flag. What are the colors on the pride flag? Green, orange, yellow. Someone help me. Look it up. Is it green after orange? Is it red, yellow, green? Red. Okay. Orange, yellow. It's 6?
Yeah, it used to be 7. Now it's red, orange, yellow, green.
Oh. Okay. Damn it. Fine. 16%, 32%, 48%, red, orange, yellow, green, blue, purple. Yeah, that was right. I think you can use calc or something here. So for 72. Sure, let's see what that looks like. Yeah. There's oh, sorry, where it does what? Yeah. The trick to doing that is to start and end at the same place. You have to. I think it's not dwelling on each of these colors the same length of time now, so you have to work that into your animation. Anyway, there's a lot of, for me at least, there's a lot of like tweak this little thing and then see how it looks and then tweak it some more. The last thing I want to show you is a nifty little CSS feature. So CSS filters. What should we call this? Psychedelic. This will be an upside down smiley. Okay. So, okay, let's see what that looks like to start. That smiley is not big enough. That smiley is too big for the page to render. Emojis have this weird problem on OS X where they don't render above a certain size. It doesn't matter how they get above that size. I think maybe if you scale them, it's fine. No, it's not even fine if you scale them. There's like, I don't understand. Like, Apple won't let their emojis get scaled above a certain size. Anyway, so while I'm hovering on this, I'm going to apply a psychedelic animation. we'll do it over 1 second, linear, infinite, I think I can say. Wow, that sounds really, it's a pretty psychedelic name, rule right there. And I'm going to apply the filter directive. Have you seen this? From 0 to, actually I wonder if this works. 360. This may not work, but let's find out. Oh. That worked. Yeah. It's pretty cool. I think it's actually better if it takes longer. Yeah. And this lets you do pretty cool effects. This is the most narcissistic thing I will ever do. But it's also kind of slow because my computer's kind of old, and it's also trying to encode this as a video. Okay. I'll let you figure out how the other effects on that page are done. They're all CSS. They're pure CSS. Okay, and then JS animations, the workshop will walk you through them. We generally prefer not to do animations in JS unless we can possibly avoid it, because it is usually jankier than doing them in CSS. All right, I believe the workshop is open. You have pairs. Are there any questions before we get started? Yeah. Wait, on which thing? What thing? Oh. Karen can answer that. All right. Anything else? Great. Enjoy hacking on animations today.
A little bit late, but I was wondering, like, you were talking about using the zero or Z0 thing.
Oh, yeah,
sort of creates a new layer. And I know that for the workshop the other day, we did like the sticky thing, and so it was like a Z of 2 for the header.
A Z index, which is different. Translate Z does not change the Z index. Translate Z moves something visually in 3D space. Translate Z index changes its stacking order.
Okay.
In 2D, like in the 2D stack of things.
But I think like so
definitely confusing.
In this lecture today, were you only talking about like changing the 3D space?
Yeah, I was just mentioning the 3D space. Yeah.
Okay.
You can't. I don't know if you can animate Z index.
Okay.
I don't think you would want to.
I was more so just wondering about it in terms of like, is it a bad thing to have like sticky elements because they're okay? No.
Cool. That's fine.
Okay.